This video explains the principle and application of relays through experiments. In a circuit, a relay acts as a switch that uses a small current and low voltage to control a large current and high voltage. Here, I have several types of relays. Although their specifications and brands differ, their working principle is the same. To give you a clearer view of how it works, I have specially disassembled one. Its working process is as follows. Here is a coil, and the coil is connected to these two pins, this one and this one. When these two pins are supplied with the specified voltage, the coil generates a magnetic field, which pushes down this metal piece above. Originally, there is a spring here, and this piece is connected to the upper part. The specific contact point that this metallic strip precisely touches signifies that the corresponding contact pin, where this particular strip is carefully positioned, is directly and securely connected to this designated pin. Subsequently, when the powerful magnetic field actively pulls this metallic strip in an upward direction, the connection that was originally on becomes disconnected, and the one that was originally off becomes connected. The same principle applies here as well. It's also made up of a coil and contact points. The only difference is that this one has two sides, meaning it can control two circuits. When the switch is not powered, this path and these two pins are connected, and these two pins are also connected. Once the coil is supplied with the specified voltage, this strip will be pulled in, causing a switching action. Originally, the middle strip is in contact with this side, but it will be attracted to the other side and connect with it. In other words, these two pins were originally the normally closed contacts. Then, after it is powered on, it becomes normally open. The ones that were not in contact before now become connected. Also, for this type, these two are the coil, but this coil, after supplying the specified voltage, this one and this one are connected. This one and this one are also connected, so if it is disconnected, they will be disconnected as well. These two pins are a coil. After both are powered, these two sides will attract each other. When the power supply stops, these two sides will disconnect. Alright, we'll use this for the experiment. To make the relay's working process more intuitive, I specifically removed the casing. These two are the coil pins, and the one in the middle is the common terminal. This one is normally open and this one is normally closed. That is, when the coil is not powered, these two pins are always connected and these two pins are always disconnected. Alright, now I'll connect the normally open pin. I've connected both the normally open terminal and the common terminal to the two probes of the multimeter using a yellow wire. These two pins are for connecting the coil, and we've hooked up a power supply, but it's currently not powered on. Pay close attention to this contact point. When there's no power, this contact is on this side, connected to the normally closed terminal. They are intricately connected together. When we apply electrical power to the coil, the central contact will be powerfully pulled down by the generated magnetic field and subsequently establish a secure connection with the normally open contact. Let's now take a closer look at this fascinating process. What happens the moment we power it on? When we turn it on, we can clearly see the movable contact shift over here, and now the two pins that were previously not connected are now in a connected state. It's 0 ohms. When we cut the power, you can see the contact disconnects and returns to its original state. Let's power it on again. Power off, it disconnects. Power on, it connects. This is the working principle of a relay.